Hello and welcome everyone to the Varsity Tutors StarCourse series, where depending on the weather near you, you may be thinking you'd rather be anywhere else, specifically a tropical island. But remember, sometimes you get stranded on tropical islands and you're in for more than you bargained for, unless you have the science skills and savvy of someone like our host today, Phil Cook, TikTok's favorite science teacher, to help you figure out how you would take a desert island and turn it into paradise, or at least something livable. And that's what we're going to do here today. So before I turn it over to Phil, you are at home with all the modern conveniences that you would have to invent on an island. So let's put them to use. There's a chat box to the right of the screen. Phil's going to ask you a lot of things about what you need to survive and what you would do in a castaway situation. So use that chat box to answer his questions and participate. Also, ask him questions throughout the class. And in the last 10 minutes or so, I'll interview him with all your questions to get us some answers. Then make sure you've got a camera nearby. Is it really a trip to a desert island if you don't have a vacation selfie to prove it? In about 35 minutes, we'll give everybody a chance to lean into the screen, take a picture with Phil, and if you upload it to Instagram, you'll be entered to win a spot in a Varsity Tutors After School Club and some autographed gear from Phil himself. So we'll make sure we cover all that when we get there. But right now, the boat is in rocky waters and turbulent waters. We are about to be marooned on a desert island. Fortunately, we have your teacher for today, Phil Cook, to help us make the best of it.
Hey everybody, how you doing? I'm so happy that we are stranded on an island together. And we're going to take a scientific approach to what we would need to do to keep ourselves alive, warm, and communicate with an outside world. I first want to start off this class though by asking you a few things, or maybe we can look at the agenda first. So let's start out with a question before we get to the agenda. I want you to think about what's in your pockets right now. Just kind of reach in. Is there anything in your pockets? If so, type in the chat box what's in your pockets right now. All right, I can see some people saying some nothing. Okay, you might not keep anything in your pockets. Others, you have keys, phones, a hair tie, okay, some money maybe. Let's see what I've got in my pockets. And because that's really, if we're marooned on a desert island, we have to go based on what we have. So I'm going to show you kind of what I happen to have in my pockets right now. And it's actually kind of beneficial that I'm wearing a lab coat because they have big pockets. I've got my phone. A lot of you actually said you have a phone. Now I've got a phone with a little charging cord that I could plug into my car. And I also have quite a bit of pocket change. It's not really going to do me much good on the island, or will it? We'll see. Got, what's left over from my lunch, just a plastic bottle, and the wrapper from my peanut butter and jelly sandwich. So each of these things are going to become integral parts in how we're going to make the most out of our castaway experience so that we can survive and thrive using science. So let's talk about our agenda for today, today's survival syllabus. We're going to start by talking about water. Then we're going to move on to things that bring the heat. Section 3 maybe is a little mysterious. We're calling that one Blame the Messenger. And then section 4, our final section, is going to be called All Charged Up. So think about what you think we're going to be covering in each of those sections. Let's start out with section 1. And I want to ask you a question. What's something that humans cannot live without? What's a fundamental thing that humans can't live without? Pop your answers in the chat. I'll give you a second to type some answers in so I can start to see what you're saying. Okay, some quick ones. Of course, water. Lots of you are saying water. Okay, food. All right, now I see some cell phones. Not necessarily sure that we have to have cell phones for survival, but they're definitely an important part of our daily lives. But absolutely water. Is something that it's critical for us to have. And if we're stranded on a desert island, we have to think about a way to get fresh water. We might be completely surrounded by miles and miles and miles of what might look like perfectly drinkable water, but salt water is not drinkable. We would have to actually process it to make it drinkable. So I wanted to show you a situation about how we could actually use some science and get drinkable water. And that's going to bring into play one of the materials from my pocket. So I'm going to take this plastic wrap. Now this is a plastic wrap that I had wrapped around my sandwich, and we're going to use this for a very specific purpose. So If we were to go to the beach, you would likely see all kinds of sand. And that sand may or may not be very damp. Kind of looks like this. Now, if you started to dig underneath though, you might notice something very different. Now, the process that I am going to talk about with you takes quite a bit of time, and that's actually something that's going to be true for several of the things that we'll talk about in today's class. But I want you to understand, we're speeding things up so that you can get the nuggets of the summary of everything. But in reality is if you're stranded on a desert island, all you have is time, and there's no rush for things. So let's go to the next slide, Brian, so we can show this basic process. So I made a video here showing you basically how you could first locate the water that's going to be a few inches under the sand in the beach. Notice there's some water there. Now, I've taken the water bottle that I saved, cut the bottom off, and I'm creating a little plastic seal over the top. This is really important because what's going to happen is that plastic is going to allow condensation to form on the top of that sheet. So when the rays of the sun heat up the sand, it's going to cause moisture from the sand to evaporate, making little droplets. Those droplets will fall into the lid of the plastic container that I've placed in the sand, and I'll have perfectly drinkable water. So my daughter actually did this series of drawings for me. So if you look at it from left to right, the big idea here is you excavate a hole, put a cup in the bottom, cover it with plastic. The condensation forms droplets on the plastic and then falls into the cup. That water doesn't contain salt anymore, perfectly drinkable, and that's a nice, easy way for you to get at least a little bit of the water that you're going to need. Now, I'll tell you, just the small little amount of water that was in the example from my demonstration, just a few milliliters in here, took on the order of 2 hours. So this would be something where you really have to set it up and be patient. And while you're being patient, you can actually start to forage for fresh water. And when you forage for fresh water in like a desert island or a deserted island, you might have trouble finding it. But what you typically are going to look for is vegetation. In fact, the lusher the vegetation, the better the chances of finding some fresh water sources. Now, just because it's fresh water doesn't mean that it's going to be clean water. So I'm going to show you how you can actually create, using some of the materials that we had with us in our pockets, a way to purify the water and make it more pure than what it was when we found it. So to start this demonstration, I've got some water that I put in a pitcher. Now this is just tap water, of course, but imagine we find some water. It's not going to look like tap water. It's probably going to have some stuff in it. So I've got some dirt here and some leaves. I'm going to add that into my pitcher. And just to make it a little more visual, I'm going to also add some red glitter. Again, this is just, think of the red glitter as like a contaminant that might be in the water supply. You're not really going to find red glitter in the water in a maroon desert island situation. So now we've got some nasty water that we would never, ever drink by itself. But what we're going to take advantage of is some natural materials that we might be able to find nearby that we can use to make a natural filter. Okay? If maybe you have a pitcher at home, that's going to use one of the components that I'm going to show you. We're going to build a little filter and see if we can take this gunky water and make it a bit cleaner. So I'm going to switch camera views now so you can see how I actually make this particular filter. So bear with me for a moment. There we go. What I have here is a plastic bottle that I had from my lunch. Now I've just kind of placed a piece of napkin here on the bottom so nothing will fall out. And I still have the top that's been cut open from when I made the cup in the first demonstration. To make a filter, what we're going to have to do is create layers in this bottle, and each layer is going to serve a specific purpose. Before I move any further, I'm going to put on some gloves because the first material that I'm going to use comes from a campfire that happened to be already on the island where I was. Looks like I'm not the only one that's been marooned there before. There was a fire, and in that fire, there was some material called charcoal. Charcoal is something that you might use at home in a barbecue. And I've got kind of fine pieces of charcoal that I'm going to use here. I'm going to put some of that charcoal in my filter. Now, charcoal is really good at absorbing odors and sediments from a water supply. So if we find a freshwater water supply and the water is quite dirty, with lots of dirt and sediment in it, charcoal should do a good job of not only removing some of the suspended solids, but also getting rid of some of the dissolved solids as well, some of the larger dissolved solids. So our first layer is charcoal. Next, something that we're going to have in abundance, beach sand. So I'm going to pour in some sand next, and that's going to form our second layer. Sand is going to be good at removing kind of intermediately sized particles from the suspension of that muddy water solution that I made. And finally, we're just going to take some gravel. Now, the gravel that I have are kind of larger rocks. Now, these just allow water to pass through it quickly, while also making sure that branches, leaves, larger pieces of material don't actually make their way through. So we've got charcoal at the bottom, then sand, and then we've got this rocky layer. So if you think about it in terms of particle size, biggest particles on the top, finer sand particles, and then even finer kind of charcoal dust. And then we've got our final little napkin that prevents any of that material from falling out. So I've got a bowl I'm going to place underneath, and I'm going to pour some of this water in, and we'll see what the water looks like as it filters through. Now, you might notice that there's definitely some darker material here. That's the charcoal. And you also might notice that up here at the top, a lot of that solid material is kind of stuck into the rocks. You might, in fact, I don't know if you can see the glitter very well, but there's quite a bit of glitter here that stops as soon as it enters into the filtering mechanism. Now, as we run this through once, we're going to remove quite a bit of the contaminated material. As we let time, here, let me switch the camera views back. As we let this filter, you might need to run it through that same filter a couple times. The core idea being each time that you let it pass through the material, you're going to be removing more and more. So if you add muddy water, murky water, that sand filter, the charcoal, and the gravel is going to do a good job of removing quite a bit of that dissolved material, but it doesn't make it pure. Remember, these materials that we have are materials we scavenged, and we're just using them to the best of our ability. Charcoal, we know, helps the water to taste better and absorbs some contaminants. Sand removes suspended particles. Okay, think about the muddy particles. And the rocks just remove the big, bulky materials from our water sample. The liquid is still going to be quite cloudy, so we're going to pour it through several times until we get to the point where the water has been clarified quite a bit. So then the question could be, well, what's going to be left? There could still be nasty kind of bugs in there. So really the best bet for us to do here so that we don't get sick, assuming that this fresh water is the point where we could boil it, is take that water, heat it up in a fire, boil it, and that would kill anything that our filter couldn't settle out. So let me see if I can show you this without making too much of a mess here. So we started with really dirty water, and we ended up with water that's a bit better, still kind of murky, but if we were to run it through again, it would get better and better every time that we passed it through our filter. So let's recap a couple of things that we've talked about so far. One of the most important things that we're going to have to think about in a castaway situation is where we get our water from. And some core ideas that I want you to keep in your mind. is we can take advantage of the sun's heat to cause evaporation to occur and then collect that water as condensation. That's what we use the plastic wrap for. The plastic wrap is hydrophobic, which means it doesn't attract to the water. That's why you might have noticed the droplets of water forming on the plastic. And we can take advantage of different materials like the charcoal, sand, and pebbles in order to separate components of a mixture and make it a little bit better for us to drink. In the case of our filter that we just created that separated the bigger pieces, the leaves and the mud from the water itself. So if that's the first thing that we want to think about, a fresh water supply, I've got a question for you to think about next. Many of you at the beginning said that you needed a way to stay warm, even though we're on a desert island, but sometimes desert islands can get quite cold at night. So I want you to think about this. You know you need to start a fire, and you know you can make a spark. What are you going to be lighting with it? So let's say that you knew how to make a spark. What would you be lighting with it? Put your answer in the comments. So think about it for a second. What would you actually use to start a fire if you know that you could just make some sparks? Right? A lot of you are saying wood, leaves, paper. Some of you say match. Okay. Probably not going to have gasoline, but somebody put gasoline in there. Yeah, but definitely we're gonna want to start with something that we know is combustible, a fuel of a type. And if we're on a deserted island, hopefully that there's going to be some wood nearby that we could collect. But actually the form of the wood makes quite a bit of difference in terms of how we're going to light it. So what we're going to take advantage of in this case is foraged materials. So I'm going to show you two things that we need for this demonstration. Now, if you're on a desert island, maybe you might find a piece of driftwood like this. Now I've taken a sharp stone and I've kind of notched out little notches on this wooden piece of driftwood. And I also found a larger kind of straighter piece of wood that is blunt on the end. This is actually pretty important for us to be able to convert energy, because all we need to do to start our fire is convert energy from one form into thermal energy, ideally to light up whatever material we have that's combustible, whatever wood that's nearby. So I want to demonstrate this process and show you how this actually works, because this is something that people have been doing for hundreds of years, if not thousands of years, using friction to generate heat. It's something that you can try right now. Put your hands together and go like this, and you'll feel that friction being converted into thermal energy. Your hands will get warmer. That's the fundamental idea behind what I'm going to show you now. So I'm going to switch camera views so that you can see this. And what I want you to pay attention to as we do this as I do this demonstration for you, I want you to look for wisps of smoke. Now, it might take a second, okay? So I want you to look right about here and see if you can see wisps of smoke. Here we go. I'm going to just you see it? It's starting to smoke already. And I can definitely smell the smell of wood that's getting so hot that it's starting to actually get to the point where we could combust it. Now, I'm going to take this board away, and I want you to notice something. When I move that board away, do you see this? This material right here? It's very, very fine pieces of wood dust. Now, I didn't do this for very long at all, but I did it long enough that you notice that there was some heat that built up. And if I show you this right here, you can see that it scorched the board. It scorched that piece of driftwood. That means we were converting that friction into heat. Now, this process actually is not nearly as fast as what you saw me do right now. All I really did in this case was show you a few examples of taking this, going like this, and generating that rotational energy, which was being pressed down onto the board, creating some friction. I want to show you what the process looks like in its entirety. And just so you know, this video is very condensed. It took me about 8 minutes for this process to actually happen. So You see in this example, I started with a little piece of pocket lint, which I happened to have in my pocket at the time. Doing the same thing that I just demonstrated for you, getting those fine little bits of wood heated up super hot. You might notice that there's a board underneath the piece of driftwood. That's the old ember that I'm going to be generating, that spark, if you will. And once I get that spark hot enough, about after 8 minutes of doing this, you might notice it started to smoke. That's where I have to be fast and immediately transfer that glowing ember into something that burns very, very well. In this case, I'm using dry leaves. If you do things right, that spark and the type of fuel that you use is perfect for you to be able to make a fire and keep yourself warm. Or more importantly, I mean, if you're on a desert island, you probably won't need to keep warm most of the time, but you could boil that water and you could make that water safe to drink now. So definitely something that using one of these will not only keep your arms in shape, but it can also help you have a safe drinking water supply to allow you to boil your water. So we've talked about kind of water, where we could get it and how we could make it safer to drink. We've talked about how we could generate some heat using friction. And some things that I want you to leave with from this particular section is it's actually quite easy to take friction and convert it into heat. Okay. The thing that I want you to understand that allows that drill, that hand drill situation to work, is we require a particle of wood that's very, very small. That fine dust of wood is what was necessary for us to have a situation where we could have good combustion. And speaking of combustion, did you catch how when I had the ember starting to smoke, I blew on it? Because in order for combustion to happen, you have to have a fuel. That's the fine particles of wood dust that I generated. You also need oxygen from the air, as well as heat. So the drill setup, the hand drill setup, gave me the heat that I needed and the fine dust of wood, the fuel. But then I used my breath to provide additional oxygen that helped that combustion process to rapidly speed up and allowed me to start a fire. So I've got another question that I want you to think about. And this one might seem a little bit of a leap, but I want you to think about, how did people send messages before texting? Before texting existed, how do you think people sent messages? Write your answer in the chat. Okay, I see you probably have gotten some holiday cards lately, so you know that people still send letters, and that's a good way to communicate. And we've also got, okay, carving into wood. All right, I wouldn't have thought of that one, but definitely that. Oh, okay, I see one that kind of fits with our lesson for the day. A message in a bottle. And that's exactly what I'm going to show you how we could do. Could we actually forage materials and make our own paper and ink to be able to send a message in a bottle? And the answer is yes. We could take advantage of lots of things that are likely to be found in a desert island situation. Fundamentally, what we're going to need is some vegetation. Doesn't really matter what, any kind of green leafy material will work. And just for a demo, I have some grass clippings that I took from my yard. They're nice and dried out. Anything would work. If it's a tropical island, you could use banana leaves. Anything that is organic in nature, you could use this. Now, what we're going to need out of this material is something called cellulose. Cellulose and lignin are two things that comprise the bulk of most kind of vegetative material. So most of this jar is grass that's made of two primary components: cellulose, which we can actually use to make paper, and then lignin. Lignin kind of makes up the cell walls of the grass cells. We don't really want the lignin. So it'd be really nice if we could process this grass. I know what you're thinking. We're on a desert island. How would we do that? I'm going to talk to you about that. How would we process this grass to get rid of that lignin, or make it so that we could remove it and leave the cellulose? Because cellulose is basically what we use to make paper. What we can take advantage of is some ashes from our campfire. That gray ashy material has a lot of a substance called potassium carbonate in it. potassium carbonate. It's commonly known as potash. Now, potash, if you add it to water, it makes the pH of the water go up, okay, making it basic. Interesting thing about lignin. When lignin is in water that has a high pH, it dissolves quite easily. So what I've done is I've taken a jar filled with the grass, added some water, and then I've added some potassium carbonate that we could get from foraging from our ashes of our campfire on the deserted island. Now check out what this looks like afterwards. Look at that. So this is water and potassium carbonate to make it basic. You might notice it does not look at all like what we started with. It's because there's still some solid material in there, but a lot of it is dissolved away. That's because it's dissolved the lignin in all of that grass clippings away. You might notice it also looks very, very dark, and we can take advantage of that for the second component of our message in a bottle. But what we're going to do now is just something that I've already done ahead of time, which is separate out that solid material, which is the cellulose, and rinsed it with water. And I've added it to a big kind of bucket that I'm going to use to actually make some paper. Now, if we were in a desert island, what would we use for this? Well, we'd have to use some branches, and we would use probably a t-shirt for the process that I'm going to show you. But nevertheless, I want to show you that we can actually take those grass clippings, take the cellulose from them, and make our own paper. Here's what it looks like. I'm going to switch to camera view so that you can see this process. So here is the container. I know it doesn't look like much, but inside this container is cellulose and water. Now, I've got a towel that I'm going to place over here on the side, and I also have a screen. Now, this screen, you could have used anything that would allow water to flow through, like pantyhose would work, or a t-shirt would work. I've just taken a piece of screen and placed it over these this frame edges. Now, what the screen's going to do is it's going to allow me to collect a thin layer of cellulose, and that should help me to be able to make a page. And we'll see if I can actually do this well. So I'm going to start by just stirring up my mix because it's been sitting most of the morning. Then I'm going to, let me see if I can show you this a little better. There we go. I'm going to take my screen in, and I'm just going to pull it out once. Now, I don't know if you can tell, but I've already got a thin layer of cellulose fibers that have stuck onto my frame. If I need to do it again, if I'm not happy with how thick it was, do it another time. Now, once this, I've got a layer that is decent, and I can usually tell that it looks relatively uniform after the second pass. I'm going to take this top screen off, set it to the side, and you might notice that we've got a thin layer of that cellulose. So I'm going to take just a moment, move this out of the way, and I'm going to show you how we can actually get that paper to release. So I've got a little piece of a towel here I'm going to use, and I've got this page. The cellulose is on the top. I'm going to flip it over, and I'm going to press down. Pressing down helps it to the cellulose fibers to stick to the towel and also to absorb a majority of the moisture, because most of this is still water. Very little of it is actually cellulose. Now I'm going to see if I can actually peel this out, peel this up, and let's see if we're left with a page with a paper sticking to a towel. Okay, it's not letting go very well. Now, the nice thing about being able to do this in a desert situation is if it doesn't work, you just put it back in the bin and you try again. See if I can at least get a little bit of this to come off so that you can see it. There, a little bit has started to detach right here. So I'm going to peel this up because I've got some that I've done earlier in preparation. can see how we get a nice little page. Here, I'll take a little bit of this off and just show you this way. Now, it doesn't have to be pretty. If we're sending an SOS message, it doesn't really matter if the paper is 8.5 by 11 or just enough for us to be able to scroll our message on. So we've got a little sample of this paper made, and all we need to do at this point is let the sun hit it, heat it up, dry it out. And when that's done, you'll be left with something that looks like this. Here's a piece that I made earlier and is allowed to dry. Now, this isn't beautiful paper by any means. It's pretty crude, but it will allow me to communicate. It will allow me to send a message in a bottle. So I'm going to take this, and then we just got to figure out a way to write a message. That's where the second component of our processing that paper comes into play. So I'm going to go back to this view. Now, if we take that liquid that was inside this container and we let it evaporate, it will form a pretty thick brown liquid. And the reason why it's so brown is because of some organic compounds called tannins. So this is an ink that we've made from processing paper out of grass clippings and allowed the extra water to evaporate. Now again, if we're going to write a message, we need an instrument to write our message. So I looked around and I found an eagle's feather. And so I'm going to use that as a quill. And so if I take some of this ink and I load it up onto my quill, I can start to write my message. And my message is going to be a simple one. I'm just going to write SOS. And hopefully, whoever gets this message will come quickly and rescue me. This ink is not the same as what you might have in your backpacks that you use at school, nor is this pen going to be one that you're going to keep forever. But you can definitely use it to make some ink and paper that's relatively strong. So now the only thing that's left is to assemble our message and toss it out in the ocean and hope for the best. So I've got a little bottle here and take our message, roll up our message tightly, shove it into our bottle. So we got our message in a bottle, put the cork on, toss it out into the ocean, and hope somebody gets our message. Some takeaways from that set of demonstrations. In order to make paper, it's all about knowing how pH affects solubility. In this case, a basic solution caused certain parts of leaves and grass to dissolve away and left behind some materials that we could use to make our paper with. So knowing how substances affect the pH of our water is something that we can use to our advantage to help communicate with the outside world. We've got some other things to think about here as we continue our journey on being a castaway in a deserted island. And it's our last section. I want you to think about this. If you could bring one thing, only one thing to the island, not just what's in your pocket. If you could bring one thing to the island, what would you bring? Take a minute and type your answer into the chat. I'll give you a second. Okay. I think a lot of you are just going off of the photo there. A lot of you are saying, my phone. Oh, that's cute. A couple of you said your dog, you bring your dog. All right. I'm not sure you could bring a boat. You would never be stranded in the first place, but I see that in the chat. You wish you could just bring a boat along with you. And, oh, okay, some people say a way to charge your phone. Okay, or in a drone. Interesting, interesting. Well, if you remember at the beginning of our lesson today, one of the things that I had in my pocket was my phone. Now, it's not got much juice left in it, but thankfully I had the cord and a little car plug-in. Doesn't really do me much good though in a castaway situation. But if we know some chemistry, we can actually take advantage of some other things that were in my pocket and what we can use those materials for. And it has all to do with the pocket change, because these coins are made out of different metals. And I can tell you right now that I know that if you put different metals together with something that conducts electricity between them, say salt water from the ocean, you can create something that a chemist calls a galvanic cell, and that you probably know as battery. Let me show you what I mean. I've got a penny here, a penny from my pocket change, and I've got a quarter, and I'm going to take these two dissimilar materials, right? The metal that makes up a quarter is a different metal than makes up a penny. A penny is mostly copper, and a quarter is going to be a mixture of metals, but there's some nickel in there. And what I'm going to do is I'm going to take these two materials and make a little sandwich, just like that. But I need to put something in between them. So remember what I said that third thing was? An electrolyte, a kind of salt water solution, something that conducts electricity. So I've got a little piece of napkin that I've soaked in some salt water that we can use in between. Now, we take this and we create this situation here. We got a little sandwich. This is a little galvanic cell. We can take this and see if we actually generate some voltage by using something called a multimeter. That lets us know if we've actually generated a voltage. So I'm going to change the camera view here. And then we're going to talk about some other options that you might have in case you don't have a lot of coins in your pocket. So if we take this, we take this coin and we connect it. See that? Goes to 0. And then when I connect it together, we get a little bit of a voltage. That's not much. And this is where we can start to actually be creative and forage around and see if there are other materials. And let's say that we go and we wander around the island and we find that there's a lemon tree, actually a lot of lemons. Lemons contain citric acid. And that citric acid, that ascorbic acid, there's actually a mixture of things inside here, is really good at acting like an electrolyte, just like salt water is. So we can actually use this lemon and make a lemon battery. And while we were walking around and finding that lemon tree, we actually found some other things. There was somebody who had been there before us, and they had tried to construct a hut. They left behind a few nails. So we can actually make a battery out of the nail, which is one type of metal, and one of the pennies that we happen to have in our pocket. So we can make, as crazy as it looks, a battery out of a nail and a penny, just like that. Now let's see if we can actually get a voltage to generate here. Let's take a look right here. Let's see if we get a voltage. Sure enough, we're getting a voltage. Now the problem is that this single little battery, this single lemon battery, isn't enough. It doesn't generate enough voltage to do what I really would like it to do, which is charge my phone. But what I can take advantage of is the fact that not only do I know about how different metals can create galvanic cells, but I also know that if you build multiples of these, you can stack them one on top of the other or connect them to one another and create something called a voltaic pile. And when you do that, the voltage builds every single time. Now to do this, it's going to take a lot of materials. And in reality, this lemon, the only thing I need from this lemon is its juice, is the electrolyte that's inside here. And I can easily kind of tear the lemon open, extract the juice, and then use that as the electrolyte between the dissimilar metals. In this case, I'm just going to use coins because I had a lot of pocket change. So I'm going to show you what I've created, and we're going to see if I can actually charge my iPhone with it. Okay? So the thing to understand about what I'm about to show you is the stack of coins that you're going to see here. It's kind of housed with a plastic sheet around it. That's just to prevent them from falling over. Again, that's just because I want to show you within a reasonable time frame the science and the chemistry of what's going on here. In reality, they tend to fall over, right? That's just the reality. You would have to find a way to kind of use some sticks to prop them up and keep that stack in a pile. Let me show you what I mean. So I've created a stack of coins that's pretty substantial, about 2 inches or so tall. And I want to see if I can show you the voltage of that stack of coins. Oh, I'm maxing it out. Change it a little bit. Look at that, 12 volts. Okay, that's super exciting because I know that this little charger, it has requirements that says DC 12 volts to 24 volts. So, all right, this is exciting. We could actually charge my iPhone. First, let's get it into view. Okay, there's my iPhone right there. Right there. Actually get this out of the way. My iPhone's right here. Cord is right in the way. Let's get that nail out of the way. Now, this part of the charger has to be connected to the negative part of the battery. So I'm going to use a piece of aluminum foil. Remember the aluminum that I had from my peanut butter and jelly sandwich. And I'm going to connect this to the bottom part of my stack of coins. Now I'm going to touch this to the top. And what I want you guys to do, pay attention right here. See if I actually can get it to charge. Sometimes it takes me a few times, but hopefully it'll work. Look at that. It's charging. Okay, let me show you one more time because I disconnected it. If you notice here, there's a green light that'll come on onto my little DC charger. Here we go. Definitely charging. Now, I don't know exactly how much charge this battery is going to give me. I had a hard enough time kind of creating it in the wild without it falling over. So I'd have to be very, very careful and I'd have to conserve my energy. But just knowing that 2 different metals separated with an electrolyte in between them can create a battery allows me to possibly send a text message to a loved one and say, hey, I'm stranded on a deserted island. Can you come help me? But we could do it. We could do it using just the materials that are in our pockets. So some takeaways from this section. Galvanic cells are fundamentally electrochemical cells or batteries. And what they do is they convert chemical potential energy into electrical energy. In this case, electrical energy that can be used to charge the battery on my cell phone. The bigger the difference in reactivity between the metals, the better the battery that you're going to actually end up with, which is why we tend to use lithium metal for most of our batteries, because lithium is a very, very reactive metal, and it tends to make very, very good high voltage batteries. So there you have it. We found a way to salvage some water and filter it if needed, start a fire to keep us warm and purify our water, make some paper out of some forest leaves and some ink, and then send a message home by creating a galvanic cell. I'm not sure what else you could ask for from if you're stuck on a desert island. That's not too shabby.
Hey, thanks so much, Bill. Not too shabby, and all done in about 40 minutes. So, think of it, you got, like you said, you got nothing but time on that island. So if you know these things, you may be able to discover all that much more. So, hey, everybody, great questions. Keep them coming. We're going to have a chance to ask Bill a few of those in just a second. Maybe he'll write his answers in quill on some homemade paper for us, or he can just say them. We're off the island now. We've got pretty good Wi-Fi connectivity. But first, let's make sure we get everybody an opportunity to take those freshly charged phones and the cameras in them. Get a picture with Phil. Reminder, if you get these up on Instagram, we'll have the official handles up here in just a second on the way out. If you get those up, tag Varsity Tutors and Phil, you'll be entered to win a spot in the Varsity Tutors After School Club. So get ready for that. Hopefully your cameras are ready, your phones are charged. Phil, we're going back full screen to you for those pictures, and then we'll get to everybody's questions.
All right, everybody. This is honestly one of my favorite times of the class, just because I love seeing the photos that you all take. So please, if you haven't gotten a phone or an iPad or a camera of some type, go grab one real quick and let's get ready to take a little selfie together. So a couple of things for props. I'll give you options. One has to be our message in a bottle. So we're going to start with our message in the bottle. And the way I'll do this is I'll do a countdown. I'll count down to 3, 2, 1, and then we'll take it. I'll kind of freeze for a second, and then we'll change out props if you want a different photo. So here we go. Ready? In 3, 2, 1. Okay. Hopefully you guys got one. The next one I want to do is I want to use the filter. So I think it looks kind of gross, and it also looks kind of cool. So I'm going to take the filter from over here, and we're going to, if you want a gross one, here we go. We're going to do this in 3, 2, 1. Okay. Hopefully you guys got a good photo. Remember, tag Varsity Tutors and tag me at ChemTeacherPhil on Instagram. And if I was your age, I would love to be able to sign up for those classes. In fact, I think I probably still could. You're never too old to learn new things.
Phil, you got an open invitation, man. So definitely, we'll make sure we get you all the links and everything. For all of you out there, we'll have the official handles up on the screen in just a few minutes here, and there should be some information on your screen also about signing up for those clubs. We can learn all kinds of crazy things. And actually, Phil, some of your content shows up in the clubhouses as well. I remember we filmed some videos not too long ago to give people some extra challenges and things to see how you can use science to do amazing things. And like Phil did, you guys have a lot of questions about them. So I think one of the most common ones, Phil, was a combination of, one, where did you learn all this stuff? And two, have you ever been stranded on an island before and gotten these things to work?
I'll answer the second question first. I've thankfully never been stranded on a deserted island. I have been lost in the woods before, but thankfully I wasn't lost long enough to need to build my own fire. I live in the Midwest, excuse me, where it gets pretty cold in the fall and in the winter. It was pretty cold, but I found my way home and I was just fine. What was the first question again?
First one was just, where do you learn all these things? This seems like the ability to come up with something out of nothing is really incredible.
Actually, you read, right? You read and you research things that are interesting to you. I mean, you might take it for granted. Like, how do we have paper in the first place? How do we make paper? And most of the paper that we make is made out of wood, like wood pulp. It's fundamentally still cellulose. So you could take anything, any kind of green vegetation, and you can make paper out of it. So I thought that was interesting. I looked up how they did it. I'm like, oh, there's a lot of chemistry involved with this. You have to have a high pH for the lignin to be able to dissolve away if you're going to just isolate the cellulose. And then, excuse me, something that you didn't see me do today, but I'd done ahead of time, is you take that cellulose, you kind of stir it in a blender. I just use a smoothie blender, and I just chop it up into very, very fine pieces, because that's what's going to give you good quality paper. And as far as the ink goes, one of the side notes with the research that I had done was you get a lot of tannin. If you or your parents, maybe your parents might collect like red wine. Red wine has a lot of tannins in it that give it kind of a woody flavor. Lots of materials have tannins in them. Tannins tend to taste very bitter, but they also have a dark color. So we can take advantage of that and make some pretty cool ink out of it. It's all research. Anything that you're curious about, just start looking it up, or ask somebody who's an expert.
Perfect. Well, that's why we bring you here, so you can do all the research, test it all out, and give us the concise and entertaining version. So a huge thank you for that. Also had a bunch of questions kind of on several of the demonstrations. One of them in the beginning was that first one where we evaporated water with the plastic bag from your sandwich. A lot of people wanted to know, where does that water come from in the sand? Is that kind of inherent in the sand itself, or had that come from water around it? And then secondly, a couple questions about hydrophobic materials. You were fortunate to have the sandwich bag with you. If we had to forage for it, where might we find hydrophobic materials like that?
Great question. So first of all, the sand, if you go to sand that's pretty close to where the ocean would be lapping up against the shore, you just have to dig a few inches, and that's just going to be salty water. If you were to just dig a hole into the sand and scoop up a cupful of that water and taste it, it'd be very salty. It's just ocean water. Sand does not remove salt from seawater. So we're taking advantage of the fact that the water's there. It just has some stuff we don't want in it, the salt. But we can take advantage of the fact that the sun is hot and provides lots of energy to be able to cause that liquid water to convert into a gas called evaporation. And then we just need something that is really the second question, which is where might we find some hydrophobic material if we don't have a sandwich wrapper? Well, if it's a tropical island, you might look out and be able to find a banana tree. Banana trees have huge leaves that are hydrophobic. They're very waxy. All you would look for is a plant, any kind of plant that would have a nice wide leaf that looks shiny. That's going to have some natural wax, and that waxiness, you could just lay that over top. Probably take a lot longer because the sunlight wouldn't penetrate as well. But nevertheless, if you have a waxy banana leaf like this, and the condensation can form on the underside, form little droplets and drip down, you can still do the same process that you saw me recreate.
Awesome. Thank you. Actually, somebody did even mention banana leaf in their question. So great question and suggestions for those who came up with it. One on the fire demo, that was another one you mentioned that took a while, and you needed to be really quick once you had gotten that heat and kind of that kind of hot, dusty material there to get it to catch something on fire and to blow the oxygen there. And I know you mentioned surface area. Can you tell us what kinds of materials should we be looking for that will burn quickly? You use dried up leaves, and why is that? What are the properties we're looking for to make sure, you even mentioned your arms were sore after creating all that friction. If we do that once, we want to harness that. What properties should we be looking for in something that's going to burn, and why is that?
Yeah, so what you really want is something with a high amount of surface area. So if you think about it just from the perspective of this board, like here's where I did the demo today. You might notice that it's got a little divot in it now. That's because when I put the drill portion of the fire starter in here, the two materials rub together. And when they rub together, this big piece of wood is ground down into tiny, tiny pieces. And each of those pieces has a lot of exposed surface area for how small it is. Okay, so what we're looking for is something technically with a high surface area to volume ratio. Right now, this piece of wood has a relatively low surface area to volume ratio. If I was to take this and hold a lighter to it, I could hold the lighter to it for quite a while. It wouldn't burn very well nor very quickly. However, if I found a sharp piece of obsidian, for example, on the beach shore, if it's a volcanic island, I could shave away pieces of this wood and increase that surface area. What you want are very, very fine shavings. Ideally, if you're on a tropical island, find a coconut. Coconut husks have a lot of fibrous, fine material. And what that means is you're gonna have a lot of surface area, and the greater the surface area, the easier it will be to take that small little ember that you'll create and be able to cause it to quickly make other material combust. Because the core thing, and it happened to me when I was doing that demonstration at home, you would get a little ember going, and then you would try and blow on it, and it would blow out because your materials weren't exactly right. So you want materials that are very fine and fibrous with lots of air in between, because one thing that you want to be able to provide that kind of campfire in the making is an opportunity to have lots of oxygen, because you have to have oxygen present in copious amounts for combustion.
Awesome. Thank you for that. And again, probably we should do a safety disclaimer. Don't try the fire demonstration at home, particularly indoors, without supervision, and don't try to filter your own water right away. It takes multiple ways through there. So we saw some fun demonstrations here. If you're stranded on a desert island, go nuts. If you're at home, let's be a little bit more careful than that. 2 more questions if we can for you, Phil. Another one, people wanted to know, hey, it's cool you charge your phone. They also wanted to know if we can start a GoFundMe to buy you a newer phone. That one seems a little bit older out there, or at least a wireless charger or something like that. But what other things might we be able to use that electricity for? That was kind of fun. Maybe you can get a little bit of signal and send a message. Maybe you can play a game to pass the time a little bit. But could we use that signal to power other things, to create fire, to do anything else that may be a little more useful to us than a phone without service?
Yeah, I mean, I think one of the way that I would probably actually use it if I was to create another kind of voltaic pile is make a little flashlight. And I can actually show you. I've got it, I had it set up. And it's actually really fun looking. So let's see if the battery is still working. Still got my cell here, move it into view, my stack. And then I'm just using a little LED. And the LED, if I touch it to the top, the sides, you could actually use that to generate some light, which might be nice. Right? This is something that you can do at home pretty easily. Make a stack of alternating metal coins, or something else that works quite well if you're going to make your own kind of galvanic cell at home is you could use Play-Doh for your electrolyte, because Play-Doh actually has quite a bit of salt in it. So you could take your different coins, put a little layer of Play-Doh in between them. So make like a sandwich with Play-Doh in the middle and make a stack of them, and then see if you can do things with it, like light up an LED. Or you could also get a little tiny motor, like a fan, create a little fan for yourself. As far as other uses, I think those would probably be the easiest to do given what you might have access to at home. Yeah, so just some Play-Doh because it conducts electricity, and some of these different colored coins, or if you have the different metals themselves, you could use galvanized nails like you saw me use with lemons and create a bunch of batteries that way and do different things with them. It's really anything you could use a battery for, you could use a voltaic pile for.
That's amazing. Thank you so much. And yeah, I think you even mentioned those LED lights are kind of an easy way to be able to tinker with that at home in a pretty safe way as well. Yes. So thank you for that. All right, last question for you. And thanks to all of you for some amazing, we had some really creative questions out here that were paragraphs long, but we'd be here all day asking some of these. What would you do in this situation? What would you do in that situation? We'll ask you the question you asked everyone else. If you could plan ahead to be a castaway, today we used what was in your pockets, including kind of an inordinate amount of pocket lint. If you could bring one thing, if you knew you would be stranded and you could bring exactly one item, what would it be and why?
I think I would probably bring, there's this product called a life straw, and the life straw is kind of, it filters instantaneously on demand almost everything out of water, makes it drinkable. So it's not like the filter that I showed you how to make today, where it's relatively crude filtration. It would remove a lot of sediment, but it still wouldn't be technically, you wouldn't want to drink it without boiling that water first. The life straw, you just stick it in the water source and you drink. Now you can't use it with salt water, but assuming you can find a freshwater source, you wouldn't have to worry about getting sick from anything that might be in the fresh water. I would definitely bring a life straw.
All right, there you have it, everybody. Phil's prioritizing water over entertainment, a smart move by an experienced scientist there. So there you have it there. The filter will work in a pinch, but you might as well have the best available equipment for you. Hey, Phil, thank you so much. Hopefully you get to enjoy, I know it's snowing where you are right now. Hopefully you get to enjoy some tropical weather at some point here soon, but not be stranded for it. Although I think all of us know that if we were ever stranded somewhere and could phone one person, you'd probably be getting that call. So thanks for sharing all these scientific secrets with us. Everybody out there, thanks for all your participation, for some amazing questions, and in advance for sharing those pictures up here on Instagram. As promised, here are the official handles that you have a chance to win a spot in a Varsity Tutors After School Club this coming January, where, as Phil mentioned, you can research and learn all kinds of exciting things. In the meantime, we wish everybody the happiest of New Year's. Stay safe wherever you are, and if you do find yourself in a jam, hopefully you can use some of these lessons you learned here today. So thanks, everybody. We'll see you back here soon.